Steps to drawing a Bohr model diagram. Okay, so first things first. We're going to draw a lithium atom. Okay, and here we have our lithium. Okay, this is what it would be, how it very basically would be represented on a periodic table of elements. Here we have our atomic number. Here we have our atomic mass, sometimes referred to as atomic weight, lithium's symbol, okay, and its name. So first we have to look at the periodic table. That'd be the first thing that we would do, okay. The second thing is to determine the number of protons. So here we would look at the atomic number. This tells us the number of protons, which is 3. Determine the number of neutrons. This is where we take the atomic mass here, okay, and we subtract the atomic number of 3. Then we figure out how many energy shells we're going to need, also called orbits, okay. We use the periods to figure that out. There is some other ways that logically we can figure that out, but this is one way to know. And then fifth, determine the number of electrons to be placed on those shells that we've just figured out by looking at the atomic number again. Okay, so our atomic number, our atomic mass, and again the atomic number to figure out electrons. So first we're going to look at the periodic table, which we have here. Okay, and determine the number of protons. So look at the atomic number. Right here, the top left of at least of our periodic table in our class is where the atomic number is, okay? So to determine the atomic number, we look at that number. Now, we could see it a little bit better here. On lithium, it is 3, okay? First, we're going to draw the nucleus. And so here's the nucleus of the atom. And then we're going to add the number of protons. So we just put a P and we write the number of protons. And we figured that out, right? If we go back, it was 3, right? That number is 3. And so we put that right here. Okay. Then we're going to determine the number of neutrons. Now we do this by taking the atomic number and subtracting the atomic mass and subtracting the atomic number. The atomic mass is found at the very bottom of each one of these elements. You can see here the atomic mass of aluminum is 26.982 right here, okay? And so the atomic mass of lithium is 6.941. So you always round the atomic number to the nearest whole number. So remember when rounding, 4 and down, round down, 5 and up, round up. So we take that number, 6.941, and it's rounded to 7 because 9 is above 5. So we take the atomic mass, our 7, and we subtract our atomic number, which was 3, and it gives us the number of neutrons, which is 4. Therefore, there are 4 neutrons. Okay, now add an n, okay, and then the number of neutrons beside it. So here's our n for neutrons and the number of neutrons. So this is our nucleus. This is what the nucleus consists of. Okay, now we need to figure out how many energy shells to use. Okay, and we're going to use the periods to do this. The numbers 1 through 7 along the side of the periodic table, okay, are the periods. Okay, they run horizontally across the periodic table. They also tell you how many shells that you'll need for a Bohr model diagram. So in this particular case, lithium is in period 2, which means that we will need 2 shells. So here we go. We're going to add lithium was in period 2, so we'll need 1, 2 shells. Okay. So now we're going to determine the number of electrons to be placed on those shells. And again, we're going to look at the atomic number. Why do we look at the atomic number when that's what we looked at for the number of protons? There's always the same number of protons and electrons in a stable element. Okay, the same number of positively charged protons and negatively charged electrons means that the element is electrically neutral. So we have our 3 protons, which are in lithium, and we have our 3 electrons that are in lithium. Together, okay, they are electrically neutral, meaning that lithium has an atomic number of 3 protons and 3 electrons that balance each other out. Okay, you can only place 2 electrons on the first shell. So remember, the first shell can only have 2 electrons. That's a rule for Bohr models. For those next 2 shells, you can only place up to 8. In this particular case, for lithium, we only have 1 left to place. This is what our Bohr diagram looks like for lithium.